Hello everybody. Today we're going to continue with Module 11, Lesson 2, Addition and Subtraction Equations. And so our essential question that you should be able to explain at the end of the lesson is how do you solve equations that contain addition or subtraction? All right, we're on page 305 of the 6th grade Go Math middle school version. So let's look at the Explore activity. All right, so a puppy weighed 6 ounces at birth. After 2 weeks, the puppy weighed 14 ounces. How much weight did the puppy gain? So here we're going to let X represent the number of ounces gained. Okay, so what do we have? We have the weight at birth, and we know that whatever the weight gained added to the 6 has to give us 14. Okay, so we're going to have weight at birth plus weight gained equals weight after 2 weeks. So 6 was given to us in the problem. The weight gained, that's what we have to find. So that's going to be our X, our unknown value. And we're setting it equal to 14 because that's how much the puppy weighed after 14 weeks. So basically, we've been answering the equation 6 plus x equals 14. All right, so algebra tiles can model some equations. An equation mat represents the two sides of an equation. Okay, so this would be our equation mat. And to solve the equation, remove the same number of tiles from both sides of the mat until the x tile is by itself on one side. And we remember we'll call that isolating the variable. Okay, so here we have 6 plus the x. Okay, 6 plus x. This part is the equals. Okay, equals what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14, all right, to represent the number 14. So how many tiles must you remove on the left side so that the x tile is by itself? Well, 1, 2, 3, 4, 5, 6. So cross out those 6. So, but now we've changed the balance of the equation. We've taken away these 6 that were there. So we have to do the same thing to the opposite side to keep the equation balanced. And so whenever you remove tiles from one side, you must remove the same number of tiles from the other side. So we need to cross out 6 on this side. All right. And now how many tiles remain on the right side of the mat? Well, we have 2, 4, 6, 8. So we can say x equals 8. So the puppy gained 8 ounces. All right, how do you know when the model shows the final solution? How do we know when the model shows the final solution? And how do you read the solution? All right, so we know that when x the x tile is alone on one side, okay? So how did we know when the model shows the final solution? So in our mat model, we crossed out the 6 ones so that the x was left by itself. The amount of tiles left on the right hand side or the other side, that's the solution. Okay, and we could check our answer by putting 8 in for x. Is 6 plus 8 14? Well, yes, it is, right? Okay, so that does check. All right, let's look at page 306. Okay, what about using subtraction to solve equations? So when removing the same number of tiles from each side of an equation, Matt, let me rephrase. The problem we just modeled in the activity was using subtraction to solve equations. So removing the same number of tiles from each side of an equation, Matt, models subtracting the same number from both sides of an equation. And that gives us the subtraction property of equality, where it says that you can subtract the same number from both sides of an equation and the two sides will remain equal. In our activity, we subtracted 6 from both sides so that the two sides remained equal. All right, when an equation contains addition, you're going to solve by subtracting the same number from both sides. Okay. So solve the example 1. Solve the equation some number plus 15 is 26. And then graph the solution on a number line. So first, notice that the number 15 is added to a. So we need to do the inverse and subtract the 15 from the side with a, so that it's by itself. But I can't just subtract 15 from the left side. I need to also do it from the right side. So we're going to subtract 15 from both sides. If I subtract 15 from 15, that leaves me 0. There's no reason to write that. I'll just say, okay, a is by itself now. A plus 0 would just be a. And subtracting 11 from 26 gives us 11. All right, well, so if the answer is 11, we should get a true statement. So let's check. Substitute 11 for a, and 11 plus 15, does that equal 26? Yes. Okay, and so if we have to graph it on the number line, there's our solution. We just put a dot there. All right, so number 2. How do you decide which number to subtract from both sides? Well, it's the number on the same side as the x, right? So subtract the number added to the variable. Okay, so how do you decide which number to subtract? So look here. So we had 15 added to a. A is our variable. So we're going to subtract the number that's added to the variable. Okay, because we want to leave a by itself. So in our example, we subtracted 15, and that left us with a. So in terms of words, what did we do? Subtract the number added to the variable so that the variable is isolated, or in other words, alone, on one side of the equation. All right, number 3. Solve the equation 5 equals w plus 1.5. So we just said we're going to subtract the number added to the variable. Well, we can switch this around, right? It doesn't matter which order we add these in. 1.5 plus w is the same thing, okay? But anyway, we need to subtract 1.5 to isolate w. So I'm going to subtract 1.5 from both sides. Okay, 1.5 take away 1.5, that's 0, right? So that isolates w. And 5 take away 1 is 4, and 4 take away a half is 3.5. So we're saying the solution is 3.5. So I don't see 3.5 on my number line, but I know it's going to be halfway between 3 and 4. Now, we can also double check our answer by plugging it into the original problem. Okay. Substitute 3.5 for W. And does 3.5 plus 1.5 equal 5? Well, 3 and 1 is 4, and half is 1, so 4 plus 1 is 5. So that's a true statement. All right, 307. All right, so that was using subtraction to solve equations. Now we're going to use addition to solve equations. And so when an equation contains subtraction, we're going to solve by adding the same number to both sides. And that brings us to the addition property of equality, where it says that you can add the same number to both sides of an equation and the two sides will remain equal. So why do we want to do that? Well, here we see that we're minusing or taking away 21 from y. We want to add 21 to both sides. Okay. So we're going to be looking for the number that is subtracted from the variable. We're going to add its opposite. So 21 plus 21, that gives us 39. So now let's check. So 39 take away 29, does that equal 18? 9 take away 1 is 8. 3 take away 2 tens is 1 10. So yeah, it does. And so we will graph our solution as 39. All right. So how do you know whether to add on both sides or subtract on both sides? Well, if the equation is an addition equation, you're going to subtract from both sides. If the equation is a subtraction equation, you're going to add. Okay, so simple as that. So let me just write our two examples. So we had a plus 15 equals 5, and we have y minus 21 equals 18. Well, this equation has addition. So to solve it, we have to subtract. This equation has subtraction. So to solve it, we have to add to both sides. Okay. All right, so solve the equation. H minus a half equals 3/4. Okay, well, I'm subtracting from the variable, so I'm going to add 1/2 to both sides. Okay, 1/2 plus negative 1/2 is 0, right? So that leaves me h, and 3/4 plus a half. Well, let's multiply 1/2 by 2 over 2 to get same denominators. And so we have 3/4 plus 2/4, which is 5/4. Or I can also rewrite that as 1 and 1/4. So h is 5/4 or 1 and 1/4. We can check our answer to see if that's correct. We can substitute 5/4 for h. 5/4 minus a half, does that equal 3/4? Well, 1/2 is the same as 2/4. 5 take away 2 is 3. So 3/4 does equal 3/4. All right, how about solving equations that represent geometric concepts? So we can write equations to represent geometric relationships. Recall that a straight line has an angle measure of 180 degrees. Two angles whose measures have a sum of 180 degrees are called supplementary. So if the sum is 180, those two angles are supplementary. If they have a sum of 90, we call those complementary angles. Okay, so let's keep those two concepts in mind. So find the measure of the unknown angle. Okay, so we know one of the angles is 60 and the other is unknown. But I noticed that if I combine this angle with this angle, it forms a straight angle. So basically, if I take the unknown angle measure and add 60 degrees to it, it's got to be 180. So the sum of the measure of an unknown angle and 60 is 180. What's the measure of the unknown angle? So x plus 60 is 180. We have addition in the equation, so we're going to subtract 60 from both sides. And so we get x is 120. If we checked, we could substitute 120 for x, and we'd ask, is 120 plus 60 180? Well, 60 and 20 is 80, so yes, 180 is 180. So our solution is 120. All right, number 6. Write and solve an equation to find the measure of the unknown angle. Tell what the variable represents. So I see here I have this acute angle here, and I have another acute angle here. They combine to form a square corner or a right angle. So these two angles are complementary. They have to equal 90 degrees. So we can do the same thing as in our example. We can say unknown angle measure plus 65 degrees, but this time it's going to equal 90. Okay, so those are our three model boxes for this equation. And so we would write the equation as the unknown measure, x, right? The unknown angle is x, plus the known, 65, equals 90. All right, so this equation has addition, so I'm going to subtract from both sides. And 90 take away 65 is 25. Okay, 60 and 20 is 80, and 5 and 5 would be 10, so 90. So we're saying x equals 25, and x is the measure of the unknown angle. All right, number 7. Write and solve an equation to find the complement of a 42-degree angle. Tell what the variable represents. So same idea. We're going to have an unknown angle measure. Plus 42 degrees. And that has to equal 90. How do I know it's 90? Because it says find its complement. All right, so our equation is going to be x plus 42 equals 90. What does x equal? Well, it has an addition, right? So we're going to subtract 42 from both sides, and we'd be left with x equals 48. X represents the unknown measure of the angle, or the unknown angle measure. So the unknown angle measure is 48 degrees. We'd also say x represents the complement. Okay. Or x represents the complement. All right, page 309. Writing real-world problems for a given equation. All right, so you can write a real-world problem for a given equation. Examine each number and mathematical operation in the equation. So write a real-world problem for the equation 21 and 79/100 plus x is 25. So examine each part of the equation. X is the unknown, right? We have to find this amount. And we know that 27 and 79/100 is being added to x. Equals 25 means that after adding 21 and 79/100 and the x, our result will be 25, or our sum will be 25. So write a real-world situation that involves adding two quantities. And here's the example they're given. Joshua wants to buy his mother flowers and a card for Mother's Day. Joshua has $25 to spend and selects roses for $21.79. How much can he spend on a card? Let x represent that amount. So you would solve the equation. $21.79 on roses plus the amount he spends on the card will be $25. So we're going to subtract $21.79 from both sides, and we see that he has $3.21 left for the Mother's Day card. Okay. All right, so how might the real world problem change if the equation were x minus 21.79 equals 25? And you still use roses for $21.79. So in this case, 21.79 is being subtracted from an unknown value. And the result is $25. All right, so in this case, if we added $21.79 to the $25, we would say that he had $46.79 to start. He bought the roses, and now he has $25 left. Okay. So number 9, write a real-world problem for the equation x minus 100 equals 140. Tell what the variable represents, then solve the equation. All right, after paying his $100 insurance bill, Tim has $40 left. How much did he have before paying the insurance bill? So, I mean, there's many possibilities, right? It just has to be some amount that you take away from 100. I mean, you take 100 away from some amount that you have, leaving you with 40. Okay, it doesn't have to be money. Okay, what does the x represent? We're going to use x to represent that amount that he had. Okay, and tell what then solve the equation. So we have x minus 100 equals 40. So we notice we have subtraction. So we're going to add 100 to both sides of the equation. That's going to leave me with x on the left-hand side and 100 plus 40 on the right-hand side. So he had $140. And that makes sense. 140 take away 100 is 40. All right, so let's practice. A total of 14 guests attended a birthday party. 3 friends stayed after the party to help clean up. How many left when the party ended? So let x represent the number of people that left. Okay, so how could we set this up? We know that there was 14 people that attended the party. So if we take the 3 friends that stayed and add the number of people that left, it'd have to be 14, right? So this could be the total number of guests at the party. We can start with number that left the party. That could be our variable. And add the number that stayed to help. Okay, so now let's plug in our numbers. The left party, we don't know. That's going to be our x. Stayed to help, we know that 3 friends stayed to help. And we know that they had a total of 14 guests. Okay, draw algebra tiles to model the equation. All right, so we have x on the left-hand side, and we have 3 ones. On the right-hand side, we have 14. All right, and we have to get x by itself. So what do we need to do? We need to cross out 3. So whatever I do to one side, I have to do the same thing to the other side. All right, and so that leaves me x equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 friends left when the party ended. All right, solve each equation and graph the solution on a number line. All right, so we have subtraction. So we're going to add. I'm going to use scratch paper for this. Okay, so I'm going to add 3 to both sides. 3 and negative 3 is 0, and 3 and 2 is 5. So does that make sense? Does 2 equal 5 minus 3? Well, of course it does. Yes, 2 equals 2. So our solution is 5. And so just graph that on the number line. It's a positive 5. So we're going to go to the right of 0. All right, number S. Number 3. S plus 12 and a half equals 14. So we have 12 and a half added to some number. So if the equation has addition, we're going to do its inverse. We're going to subtract both sides. Okay, if I subtract 12 and a half from 12 and a half, that's going to give me 0. But I have to do the same thing to the opposite, to the other side. So that's going to leave me S equals. Well, what's 14 take away 12 and a half? Well, I know 14 take away 12 is 2, and 2 take away a half is 1 and a half. So we're saying that S is 1 and a half. Does that make sense? S plus 12 and a half equals 14. Substitute 1 and a half for S. And does that equal 14? 12 plus 1 is 13. Half plus half is 1. 13 plus 1 is 14. So 1 and a half. Where's that on the number line? It's going to be exactly between 1 and 2. All right, solve each equation. H plus 6 and 9/10 equals 11 and 4/10. Okay, so we have addition. So to get the H isolated or by itself, we're going to subtract that 6 and 9/10 from both sides. 6 and a half take away 6 and 9/10 take away 6 and 9/10 is 0. So I'm left with H on the left-hand side. And now I have to take 6.9 from 11 and 4/10. I can't take 9/10 from 4/10, so let's regroup and trade one of the ones for 10/10. So that now gives me 14/10. 14 take away 9/10 is 5/10. 0 minus 6. I can't take 6 ones from nothing. So I'm going to have to regroup from the 10 and give 10 ones to the ones place. 10 take away 6 is 4. So we get an answer of 4 and a half. Let's check to see if we're right. So again, our equation was 6 and 9/10 plus H is 11 and 4/10. We're saying that H is 4 and a half. We need to find out if when we add those two numbers together, does that give us 11 and 4/10? Well, 9 and 5/10 is 14/10, or 1 and 4/10. 6 and 4 is 10, plus the one regrouped one, 11 and 4/10. So yes, they do check. Okay. Number 5. 82 plus some number is 122. And we see addition, so we're going to do the opposite and subtract. We'll be left with P on the left side. And 142 minus 82 is 40. Okay. 2 take away 2 is 0, and 12 take away 8 is 4. Okay, so we're saying P is 40 for number 5. If we substitute 82 plus 40 equals 122. 2 plus 0 is 2 ones, and 8 and 4/10 is 12/10. And 122 does equal 122. All right, number 6. We do have some room here on this side here. So we'll go ahead and solve it there. So we have addition. I'm going to do its opposite by subtracting 1/2. That'll leave me n on this side, and 7/4 minus 2/4. Okay, I found a common denominator by multiplying 1/2 by 2 over 2. And 7/4 minus 2/4 is 5/4. Okay, we can check our answer. 5/4 plus 1/2, does that equal 7/4? 5/4, 1/2 is the same as 2/4. And 5/4 plus 2/4 is 7/4. 3/4. Okay, number 7. Write and solve an equation to find the measure of the unknown angle and tell what the variable represents. Okay, so we're going to have the measure of an unknown angle plus 45 equals what? Does that equal a 90-degree angle or a straight line? It equals a straight line, so 180. So that's going to be, if you're using the boxes to set up your equation, the measure of the unknown angle we'll call x plus 45 equals 180. We're going to subtract 45 from both sides. That isolates the x, and the x would be 135 degrees. Okay, so what was the equation we used? We have x plus 45 equals 180. The unknown angle is 135 degrees, and x equals the unknown angle measure. All right, number 8. Write a real-world problem for the equation x minus 75 equals 200. I'm going to think of it as like a piece of lumber. And so all right, so after cutting off 75 centimeters from a piece of board, it left 200 centimeters. How long was the original board? And let's let x be that amount. Okay, so we have some amount minus 75 equals 200. So we know that we have subtraction, so we need to do the inverse. We're going to add 75. Okay, why are we adding 75? Because that's going to isolate the x. It's going to it's basically like moving the 75 from one side of the tile mat to the other side. I'm sorry, removing them from the left-hand side as well as on the right-hand side. All right, so we removed 75 by adding, we removed the negative 75 by adding 75. And so 200 plus 75 is 275. So x equals 275 centimeters. All right, 9. How do you solve equations that contain addition or subtraction? Well, we've actually talked about this already. If it has addition, you're going to subtract. If it has subtraction, you're going to add. Okay, which is basically use the inverse operations. let's look at 311. Page 311, number 10. Write and solve an equation to answer each question. Tell what the variable represents. All right, so a wildlife reserve had 8 elephant calves born during the summer and now has 31 total elephants. How many elephants were in the reserve before summer began? Well, okay, so what do we know? We know that there were 8 calves that were born during the summer, and now there are 31. So we know that if we add elephants already in reserve plus the elephant calves, that's going to give us the total number of elephants. All right, so elephants already in the reserve. Well, that question didn't tell us that. We have to find that out. So that's going to be my x. They did tell us that there were 8 elephant calves born, and that now gave us 31. So our equation is x plus 8 equals 31. Okay, so what can we do to solve that? Well, we're going to subtract 8 from both sides. I'm going to use the inverse operation of addition to both sides of the problem. By subtracting 8, that leaves me 0. And 31 take away 8 leaves me 23. So 23 elephants before summer. X represents number of elephants before the summer. All right, number 11. My sister is 14 years old. My brother says that his age minus 12 is equal to my sister's age. How old is my brother? All right, so we know the sister is 14 years old. My brother says that his age minus 12 is equal to my sister's age. How old is my brother? Okay, so let's look at this. So brother's age. We don't know the brother's age. But if we subtract 12, that's going to be the sister's age. All right, so which ones don't we know? We know the sister is 14. Okay, it says my sister is 14 years old. So let's subtract. Let's call the brother X minus 12 is 14. So our equation is X minus 12 equals 14. So what is that answer? We're going to do the inverse operation of subtraction. So we're going to add 12. That leaves us X on the left-hand side of the equation. And 14 plus 12 is 26. So we would say the brother is 26 years old. X represents the brother's age. All right, number 12. Kim bought a poster that cost $8.95 and some colored pencils. The total cost was $21.35. How much did the color pencils cost? Okay, so we know that the cost of the poster plus the color pencils equals the total cost. Okay. Right? In the problem, they told us that the cost of the poster was $8.95. We have to figure out the cost of the colored pencils, and she spent $21.35. So that's our basic equation. Does it matter if I have the x first? No. Okay. You could have said color pencils plus color poster equals 21.35. This is the same thing, right? Commutative property of addition. Okay. So 8.95 plus x equals 21.35. What does x equal? X equals, we're going to subtract 8.95 from both sides. We'll be left with x on the left-hand side. We're subtracting 8.95 from both sides. 0, I can't subtract 9/10 from 3/10, so we'll regroup. 13 take away 9 is 4. I can't take 0. I can't take 8 from 0, so we'll regroup. And it gives us $12.40. X represents cost of color pencils. Okay, 13. Acme cars sell 37 vehicles in June. How many compact cars were sold in June? Okay, well, we have a total of 37 vehicles in June. So we know that the June sales were 34. 8 of them were SUVs, and we have to figure out the rest were compacts. Okay, well, let's call that X. So X plus 8 is 34. Not 34. 37. It says 37. I don't know why I wrote 34. Anyway, I did it twice. X plus 8 equals 27. So we're going to subtract 8 from both sides because this side that has the x is addition. So subtract 8. That will leave me with x. And 37 take away 28 is 29. So 29 compact cars were sold in June. If we were wanted to do boxes to start this problem, we would have said compact cars plus SUV equals total cars sold. All right, number 14. Sandra wants to buy a new MP3 player that is on sale for $95. She has saved $73. How much more money does she need? Okay, so we know she has a certain amount, right? So we know she has money saved plus some amount plus money needed. Okay, so money saved plus money needed equals cost of MP3. All right, well, the money saved is 73. We don't know the amount of money yet that she needs to save, or needs the more money she needs. But we do know the total cost is 75. So 73 plus x equals 95. This side has addition, so use the inverse and subtract. So x equals $22. Okay, 15. Ronald spent $124 $3.45 on school clothes. He counted his money and discovered that he had $36.55 left. How much money did he have originally? So we can use this as a subtraction problem. We can say his original money minus the amount spent equals money left. Okay, and so plug in what we know. We don't know his original amount. We have to figure that out. We do know that the amount he spent was $123.45. And that left him $36.55. Okay, well, I see that I'm subtracting from x. So I'm going to do the inverse and add 123.45 to both sides. I'm going to be left with x on the left-hand side. And on the right-hand side, I'd be left with 200, or have $160. Okay, 5 and 5 is 10, regroup. 5 and 4 plus the regrouped is 10, regroup. 6 and 3 is 9, plus 1 is 10, regroup. 3 and 2 is 5, plus the regrouped is 6, and 1 plus nothing is 1, so $160. All right, 16. Brita withdrew. That means minus. That means she took it away, right? After her withdrawal, there was $548 left in her account. How much money did Brita have in her account before the withdrawal? Okay, so we don't know the amount before the withdrawal. She then goes in and takes away $225, leaving her $548. Okay, well, I'm going to do the inverse operation and add 225 to both sides. I'm going to be left with x on the left-hand side, and my sum on the right-hand side is $773 before withdrawal. Before the withdrawal. All right, 17. Write a real-world situation that can be represented by 15 plus something is 1750. Tell what the variable represents, then solve the equation and describe what your answer represents for the problem situation. All right, so the amount she spent on the binder, the notebook, and the pencils is $15, plus the eraser cost equals $17.50. So if we subtract 15 from both sides, she would be left with $2.50 for the erasers. X represents cost of erasers. Right, number 18. Paula solved the equation 7 plus x equals 10 and got 17. She's not certain that her answer is correct. How could you explain her mistake to her? Well, since this is addition on this side with the variable, she has to subtract 7 from 10. She has to subtract 7 from both sides. So the only way to get 17 is if she added 7. But adding 7 to both sides, she wouldn't get x by itself. Okay, so she should subtract 7 from both sides. Her solution should be 3, not 17. All right, 19. A grocery store is having a sales this week. If you buy a 5-pound bag of apples for the regular price, you can get another bag for $1.49. If you buy a 5-pound bag of oranges at the regular price, you can get another bag for $2.49. All right. So write an equation to find the discount for each situation using A for the amount of the discount for apples and R for the amount of the discount for oranges. All right. So basically, we have $1.49. That was the discount. Plus A will give us $2.99. And the oranges would be $2.49 plus R equals $3.99. So that's going to tell us the amount. So if they're spending $1.49 plus the amount of the discount, would get it back to the original price of $2.99. With a discount of $2.49, I'm sorry, with a sales price of $2.49 plus the discount will get you back to the original amount. So which fruit has a greater discount? And we need to explain. Well, in A, $2.99 minus $1.49 would be $1.50. And this one, if we subtract $2.49 from both sides, we get a discount of $1.50. So they both have the same discount. Right, 20A. An orchestra has twice as many woodwind instruments as brass instruments. There are a total of 150 brass and woodwind instruments. Write 2 different addition equations that describe this situation. Well, so let's do some basics. WW is just going to represent woodwinds plus brass equals total of woodwinds and brass. Okay, so if you add the woodwinds and the brass, you can get 150. Okay, so we need to write 2 equations. Well, there's twice as many woodwind as brass. So we can say that woodwinds equals 2 times the brass instruments. If you tell me the brass instrument amount, I can tell you what the woodwinds are. Okay, so that basically, I could say the equation then would be W, the woodwind, plus 2 times the amount of the brass would be 150. Or we can say that W equals I'm sorry, not woodwinds plus brass is at 150. W is twice as many brass, so that's 2Bs. So we can rewrite that as 2 times B. So whatever the amount of the brass is, let's say it's 5, the woodwinds would be 10, because we'd have to go 2 times 5. Okay, so how many woodwinds and brass instruments must there be? Well, let's think about this. So if we do B plus B plus B, that has to be 150. 3 times what is 150? 3 times what equals 150? Well, 3 times 50, right? So the brass has to be 50, and woodwinds would be twice as much. So what's twice 50? 100. Right, 21A. Assume the following. A added to 1 gives you 2, and B added to 10 gives you 20, and C plus 100 equals 200, and so on. Solve each equation. Okay, well, in this one we're going to subtract 1 from both sides. That would give us A equals 1. Subtract 10. That would give us B equals 10. C plus 100. Subtract 100 from both sides. So C equals 100. That looks like it's increasing by 10, right? By a factor of 10. Subtract 1,000. So D equals 1,000. What pattern do you notice? Okay. And what would be the value of G if the pattern continued? Well, if D is 1,000, E would be 10,000, F would be 100,000, and G would be 1,000,000. Okay, how did I get that? Well, again, it's just increasing by 10 from the previous one. So if I multiply D by 10, I'm going to add 1 0. Then if I multiply F by 10, E by 10, that'll give me F, which would be 5 zeros. And if I multiply F by 10, it would give me G with 6 zeros, or 1,000,000. Okay. All right, so that's it for our lesson on adding and subtraction equations. In our next lesson, we'll be working with multiplication and division equations. So until then, I'll see you soon.